Hi, I want to apologize up front because undoubtedly before I finish this lecture I'll be coughing or sneezing. I have a cold at the time of this lecture, so please bear with me. This is an introduction to object-oriented programming, and it's assumed that the student watching this has had the equivalent of the CS1 or at Anderson University, the CPSC 1400 course, that you've done programming to the extent that you have worked with objects, you have worked with pre-written classes and objects, and that you're familiar with some of the basic elements of programming to include control of flow. So we're going to take a look at what classes and objects are, and this was first introduced in the CS1 class at Anderson University early on, maybe the first week, and at that point in time everything was new, and I'm not sure that this resonated all that well, but we'll take a second look, and I think this time around it'll make even more sense. So the idea is that in object-oriented programming languages, we recognize things in our environment that we need to manipulate in program code, and we encapsulate those things in terms of their properties and their methods, or in terms of their attributes and their behaviors. And so what I've done in an example program that I'm going to show you shortly is to take something that's familiar in the real world to all of us, a die, and take that thing and treat it in software as a class, and then when I use the class, I will, as the term applies, I will instantiate it. I'll create an instance of the class or multiple instances of the class and use that pre-written code that I've created. So let me push on with this idea. So in the real world, I recognize there is this thing called a die, and it's used in many games and many board games. The typical die has 6 sides, and each side has a certain number of dots, otherwise known as pips. And the standard die would have a side with 1 pip, another side with 2 pips, and continue on in that fashion to a 6th side with 6 pips. So we're going to create something in software that could be used with a video game, the way a die could be, and in order to create the attributes and create the functionality or the behaviors of that object, I'm going to write what is known as a class, and that class is going to be named CLS Dice. So assume for the moment that CLS Dice has been written, the class CLS Dice has been written. Then if I create an application, I could use that class, I could incorporate that class and create instances of it, or instantiate the class as many times as I want to, and I could create a working copy of the class and call it OBJ-Die1. I could create a separate instance of the class, working copy of the class, and call it OBJ-Die2. And each instance of the class can use the behaviors that are built into the class by the programmer, and they can store data according to the attributes that have been designed into the class by the programmer. But each die can function independently, so each object can function independently. So OBJ-Die1, an instance of CLS Dice, otherwise known as an object, could have in its properties certain stored values, and OBJ-Die2, a separate instance of the CLS Dice class, could have stored in its equivalent properties different property values. So even though the objects have the capability of storing the same things or exhibiting the same behavior, they still work independently and they store separate sets of data. Okay, so hopefully that'll make sense here in a moment. I'm going to back up to the course outline here and go through some of the terms that I've identified here, and hopefully by introducing this terminology up front, when I actually do an analysis of the program code, it's going to make it a little easier to understand. So I've already mentioned, and I will continue to mention, the terms class and object. Okay, so what you need to understand is that as a programmer who recognizes things that need to be manipulated in the software that you're writing, you will create classes. Okay, and those classes then are the origins of the program code. And at runtime, if you create other applications, rather than having to repeat that program code in your applications, you can go back and use the program code that has previously been written for a specific thing. So pretend that there's two programmers. One is writing a board game to play play Yahtzee, and a second programmer is writing a board game to play the game of aggravation. Both of those games use dice, that would be the plural, use dice, and so one way of making the board games work would be for the first programmer to write all the program code that relates to rolling these things called dice, and the second programmer writes the equivalent program code, maybe writes it a little bit differently, but nevertheless writes the equivalent program code to create, again, the same thing we call dice. And if someone else, a third programmer, decides to write a backgammon game, they might also have to write the program code that the other two programmers created. And so over and over again, the same thing is needed in a variety of board games. So one approach would be just to continually rewrite it. Another approach, and a better approach, would be that someone take the time, carefully study the details of what functions and what attributes a die has, and then write the program code one time, test it, make sure that it works properly, and then make that program code available to programmers 1, 2, and 3. And that eliminates programmers 1, 2, and 3 each having to write that same program code. They can concentrate on the details of their individual games, but at the same time, when they need that functionality that's common among all three, then they can just essentially import the program code, from that outside source. And so that's the idea of object-oriented programming and writing classes. If we identify enough of these things in the real-world environment, whether it's a card or a die or whatever the kind of object might be, then if the program code is written correctly, so that it is written in such a way that it is able to be used by a wide variety of applications, and if it's tested and it is put into a form where it can be conveniently distributed, then we can utilize it over and over again and share it among a maximum number of people. So we will be writing classes, and those classes, when they are actually used by applications, will be instantiated. That is to say, the class will be made available to the program, and an instance of the class, a working copy of the class, will be made available to each of the specific programs. So an object is an instance of a class. Okay, this will become more apparent as we look at the program code, but if you can somehow, get a handle on that bigger concept, then it'll make things easier as we go along. Instantiate means that we create an instance of, or that we derive an object from a class, and there is a certain way in programming that we create an instance of a class. Okay, so there is going to be a certain way to write the program code in order to instantiate a class. Classes have methods, actions that they can perform, and objects have methods, actions that they can perform, and properties are the attributes that objects have. So as we write a class, we have to attend to the actions and the attributes that we want the eventual objects to be able to have and to perform. When we create classes, we will use what are known as getters and setters to create the properties of the class. So as we write the program code that constitutes the class, there is something new that we have to learn, and those new things that we have to learn that relate to the properties of the class, the data that's going to be stored in the class, are called getters and setters. And I'm going to use these terms interchangeably, and there are a couple of other terms that are used also, so synonymously. Getters are known as accessor methods, and setters are known as mutator methods. And it gets a little bit confusing because we think that a object has properties and methods, yet when I talk about accessor methods and mutator methods, these are things that are used strictly in the creation of the properties. So it'll become clearer, but what you can take away right now is that if I mention accessor methods or mutator methods, I'm really not talking about the actions of the class, but rather I'm talking about the properties of the class. And also understand that there are two synonyms that are used, getters and setters, and I will probably favor using getters and setters over talking about accessor or mutator methods. Private and public. Private essentially means that if I label something private, whether it's a property, or whether it's a variable, or whether it's a method, then it can be used within an instance of a class. So that makes it accessible anywhere within an instance of a class, anywhere within an object that's derived from a class. It allows it to be used anywhere within the object that's derived from a class. If I make something public, it makes that thing, be it a method, a variable, a property, it makes that thing available to any object that instantiates that class. So if I create a die class, for instance, and I instantiate it in a Windows form object, if there are public methods within that die class, those methods become available to the Windows form object. If there are methods variables or properties that are labeled private in the die class, then they remain only usable within the die object. So if the Form1 object instantiates the die class, if there are methods, properties, variables that are marked private, that Windows form does not have access to them. They remain only available to that object as internal components. That will become clearer, I think, as we proceed. Static means that a memory location is shared. So if I have a class and I have marked a component static, then it will be available, that single memory location will be available to any object that is derived from that class. A better way of saying it is that memory location will become available to all objects that are derived from that class. And I'm going to be using a static property in the example that I show you, so be heads up to that. And I would say right now, just mentally catalog that as meaning that that is a shared memory location. Okay, so I'll have a lot more to say about that later on, but just be heads up to this idea, and then we'll see that as it's applied in a concrete way. Finally, constructor is a special purpose method or methods. There can be more than one constructor. It's a special purpose method or methods that are written in a class, and they are methods that execute when the class is instantiated. So if there's some kind of startup activity that needs to occur when a class is transformed into an object at runtime, then the program code that's needed can be put into the constructor. And again, we'll see an example of that. So I do want to try to clarify this just a little bit up front, though. A class can have more than one constructor, but when the class is instantiated, only one of those possible many constructors will execute. And that constructor will execute automatically at the time the class is instantiated. And then finally, what I want to say is the constructor will execute when the class is instantiated, but if the constructor does not contain any program code, then it has a benign effect. So we can instantiate a class, create an object from a class, and call up its constructor, but if its constructor is empty of program code, then nothing happens. So you don't necessarily have to force something to happen when a class is instantiated. All right, I will continue on. And I'm going to switch over here to a program that I've given you that is the first example of a class. And if we look at Solution Explorer, let's take a look at what's in here. There's three things that are of significance. There's a file called clsdice.cs. That is a class, okay? And Form1, that is a standard Windows form class. Form2 is a standard Windows form class. clsdice is a class that I have written myself. It's a custom class. Now, instead of putting all the program code that's needed to make this application act like it is rolling dice, instead of putting all that program code in the Windows form itself, in button click events, or even in private methods, what I've chosen to do is to take all that, the behaviors, all of the data, the attributes of the thing that I logically think of as a die, and put it in a single file, in a single program element called CLS dice. And then when this form needs to roll the dice, reset the dice, whatever it may want to do in terms of interacting with the die, then it will be making calls to public methods and public properties in the CLS dice class. Now, I should go back and say this. The form will instantiate the CLS dice class. Okay, so this form will start up, then there will be some program code within this form that will bring working copies of the CLS dice class, bring in those objects, and then the form will use their built-in methods and properties in order to accomplish whatever it is that it needs to do. A final comment in this regard is that because I've taken so much of the functionality and so much of the data that's needed in order to represent this thing that I call a die, because I've taken so much of that and put it in this file called clsdice.cs, that means that I don't have to include it in this Windows form class. And consequently, the amount of program code in this CLS or in this Windows form class is greatly reduced. So you're going to see as we look at this that it's fairly sparse, and that the program code that is contained in this Windows form class is really just program code that either calls upon the functionality or the data that's in the CLS in the instance of the CLS dice class, or it contains program code that directly manipulates things in the interface, that clears text boxes and does things of that nature. So let me run the program. Let's take a look and see from the user's perspective, not knowing anything at all about the way the program's written or organized. Let's see what the user would see. The user sees a Windows form, and in the interface there are interface components that allow two instances of this dice class to be interacted with. In other words, we have in this Windows form the controls that allow us to pretend to manipulate two different die. So I have die 1, die 2, and obviously if I'm going to use a die, I can sit there and look at it. I can, stare at it all I want to, but if I want to really interact with it, my principal behavior that I want to try to invoke from the die is a roll. So I'm going to roll the die, and if it is a standard die, it's going to have 6 sides, and again on side 1 there's 1 pip, side 2 there's 2 pips, and that continues on to side 6 where there's 6 pips. And as I have rolled this die for the first time, notice total rolls is 1, the current value is 6, so I rolled a 6. And this total pips is maybe a bit confusing the way it's labeled, but that's just telling me what's the maximum number of sides on the die. I should have said, total number of sides on the die or something like that. So I'm working with a 6-sided die right now, and I roll it a second time, and this time it rolls a 3, which is within range. That's my second roll. Notice over here that when I rolled the first time it shows a value of 1, second time a value of 2. I'll give you a heads up. The total rolls property that is built into this CLS dice class is a static property, which means that all the instances of dice that are derived from CLS dice are gonna share a common memory location. So if I roll my second die, it rolls a value of 1 on a 6-sided die, and the total rolls is 3. And if I roll that second die again, total rolls is 4, it rolls a value of 2. So total rolls is a value that corresponds with the number of rolls as a sum of the rolls between die 1 and die 2. Okay, so it's possible to reset the die. If I click that, notice that it clears out that shared memory location. If I roll again, it rolls a 6 and it treats it as a brand new game or something, and so total rolls is now reset to 1. I can also reset this die, and this is where anything's possible in software, I suppose, but unlike the die that you actually use in a physical board game, physical die that you use in a physical board game, which have a set number of sides and really can't be altered. This software die can. One of the things I can do is I can put in, let's say, 200, and I can create a 200-sided die, and then if I reset with that value, instead of having a 6-sided die, which is the default, I'm going to now have a 200-sided die, and if I roll, it shows me now my current value is 129, which is within the range of 1 to 200, and that's my first roll. And if I roll the second die, it's still set to the default number of sides of 6. All right, so hopefully that gives you some idea of what kind of functionality there is in this this program. So I'm going to close this up, and the next thing I'm going to do is take a look at the CLS Dice class. Hi, I'm back again. Just before the last transition, I indicated that I was going to analyze program code in the class CLS Dice, and I've decided that I'm going to do that a little bit differently. Rather than start looking at that program code, which is a bit overwhelming, what I'm going to do is look at some example statements so that you have some idea of what's going on before I overwhelm you with so many lines of code. So here's some things to understand as I go about my explanation. First of all, I'm assuming there is an instantiating object, which in the program code that I've written will be form1. So at runtime, form1 becomes an object, and then it instantiates the class CLS Dice and makes a working copy of it. Okay, so a couple of terms now to be heads up to. The object that is instantiated is known as the instantiated object. The object that performs the instantiation will be the instantiating object. Again, form1 in the actual program example, form1 will be the instantiating object, and CLS Dice will be the instantiated class. All right, so how does the instantiating object instantiate a class? It does it with a line of code that should be familiar or look somewhat familiar. And in this line of code that I have highlighted, the variable obj_dice1 is used as an object variable, so it's going to be our object representation, and it is declared to be private, which means it's going to be a class level variable. That object can be used throughout the instantiating object, so it can be used throughout form1. It's going to be a variable of type CLS Dice, the same as my class name. Then equal new means that we create a new instance of the class. So at that point, the object goes into existence, and then what follows is a call to the constructor, or that special purpose method that executes at the moment that the object is that the class is instantiated. So there is a constructor that has no parameters, And again, all constructors are named the same as the name of the class itself. I also show you in a comment statement how we could instantiate the class a little bit differently. Again, I create an object by the same name, and I instantiate the class with the keyword new, but in this case there's an overloaded constructor, or another constructor by the same name obviously, that has a different signature, and that second constructor then has one integer parameter. So if I wanted to call up that other constructor, I would need to do it the way I've shown, minus the / comment. Alright, so that's how the class is transformed into an object, and thereafter that object's public properties and public methods are available to the instantiating object when the instantiating object references either the object name.property or object name.method. So let's take a look at some lines of code that do various things. In my second example code, what I'm doing is, from the standpoint of the instantiating object, again form 1 if you want to look at it that way, I want to read some existing data that's stored in that object. So if I want to get a copy of what's in an instantiated object's public property, then I could do it by a way of an assignment statement. In this case, I'm going to declare a variable of type integer and name it val, so it's a local variable of type integer named val, and I assign it whatever is in the object's public property total pips. That public property is integer, so it has a data type associated with it, and therefore I'm able to assign that stored value to a local integer variable in the instantiating class, in the instantiating object, excuse me. Alright, so that's how I would read an existing property value. If I want to write to a public property, then I'll use an assignment statement, but I'm going to reverse things. The target of the assignment is going to be the object's property. So again, obj.die1 is the object, .totalPips is the public property, and if I make it the target, I could assign it, for instance, the contents of text box 1 converted to int32. So that's how I write to the properties. Now, there is a particular structure that we use that I explained previously called a public accessor method, or I said I would refer to it as a getter. So read implies that I am going to use the public portal for reading called the getter, and writing means that I'm going to use the public the public mutator method, or other words the setter, and I'll be writing or putting a value into the object's property by way of the setter. Okay, and how do I do that? I reference again the object's public property, that would be the setter name, and I assign it something that is of a compatible data type. So that's how I'm going to manipulate the properties and go through the public accessor and mutator methods. Then to invoke the object's methods, I'll show some examples. One type of method that I could call up would be a public void type method, and to do so I would name the object dot name the method. Okay, so just by saying object dot reset, object obj dice1 dot reset, I'm able to call up the object's void type reset method. Okay, so that's pretty straightforward. If that method happens to use a parameter, then I could call it up the same way, except I would need to put something in the argument list that is of the same data type as the public method's parameter. So in this case, if the public method's parameter is integer, I could take the contents of text box 1, convert it to int32, and use it as an argument. Again, within the instantiating object, I might want to call up a return type method, and I have one named objdice. I have one named roll, which is again part of the object objdice1. And so to call up a return type method, I would provide some target location in an assignment statement, and then invoke that public return type method by saying object.methodName. So it's not all that much different than working with private methods. And so I wanted to show you just the fundamentals of calling up the constructor and using the properties both to read from and write to, and then show you examples of how a object's methods can be accessed. And again, if you are familiar with how private methods work, then there's not a whole lot of difference when we're looking at public methods, other than we have to reference the name of the object in the process. Okay, so hopefully that's going to be helpful as we start looking at actual program code, and I think I'm going to make this part 2, and then go ahead and do the actual code analysis of both Form 1, the instantiating object, and CLS dice, which will eventually be my instantiated object. So I'll do the actual code analysis next. Okay, so this is part 3 of Module 2, and I'm going to take a look at some program code that's in the instantiated class. So again, in our context, that's going to be CLS dice. I don't want to actually show you CLS dice yet, still holding off because the amount of code is so overwhelming, but instead I'll show you some isolated examples. And so starting out, we're going to take a look at how a getter is constructed, okay, and this will provide read access to data that is otherwise private inside of the instantiated object. So in the instantiated object, the actual data that makes up the property value is stored in a private variable known as a member variable, and if something external to that instantiated object needs access, it has to go through some public portal. So this public portal for read access begins with a header that reads public, followed by the data type of the property that it needs to access, followed by the property name, which is usually descriptive of the attribute. Then there's a set of parentheses that frames the entire structure, and within the structure then for read access we have what's called a getter that begins with the keyword get, and inside of framed braces at a minimum what I need is a return statement, and it would return the value stored in a private variable. Okay, so again, provides a public portal to what would otherwise be private data that would be inaccessible from the outside. To look at a concrete example of this, beginning with the keyword public, we're followed by a specific data type, followed by a property name, and then again framed within the overall set of braces is the keyword get, and then at a minimum the code that's needed is a return statement that returns the value in the member variable. Now I said at a minimum there could be additional program code in there, so we can build in decision logic and try catch and a number of other features to provide some enhancements to the property, but this is the actual bare minimum amount of code that's necessary. And I'll demonstrate that to begin with because there's no point in creating any additional distractions. All right, so that would be from the standpoint of the instantiated object, the program code that makes up the public portal for reading. And again, from that same perspective, from the instantiated object, the public portal that's used for writing to the private memory location to actually change the property value from the external source. We create a public portal called a setter, and it begins as the getter does with keyword public, followed by the data type that we intend to of the member variable that we intend to change, followed by the property name that we want to reference it by. And then we have within the overall structure, the outer braces, a portion of it that begins with the keyword set, and in the setter, the minimum amount of code that's necessary is an assignment statement where we assign to the member variable that represents the actual stored data for the property a generic parameter, the value that's in the generic parameter named value. So value is a keyword, and that represents just a generic parameter for this structure. And then a concrete example would be, as I've described here, keyword public, name of the data type, name of the property, and then within the overall structure, we have a set, keyword set, followed by a pair of braces, and within that, the minimum amount of code that we would need would be an assignment statement where we assign the generic property, the generic parameter, in this case to the specific class level variable named m total pips. Okay. Now, as with private methods, private methods would be the best way to compare this. As with private methods, there's two parts. There's a part where we have to look at the structure of the method itself, and then we also have to look at how do we call it up. So let's take a look at that and look at some of the statements we've looked at previously. So if I go back to page 2 in the Word document, you'll notice that item 2 says within the instantiating object, here's how we read or get a stored existing property value. And the way that's done is through an assignment statement. So in our case, in Form 1, there's going to be a local variable named val declared to be of int data type, and then we would assign the stored value in the instantiated object by referencing the object name dot property name, and that's the same name that appears in the header. That's not the name of the member variable that actually stores the value, but rather the name of the property that appears in the header of the portal. So we take the existing value from the instantiated object and assign it to a variable in our instantiating object. And we go through a getter to do that. Now if we want to go the other direction and write, if we want to take a value that's in our instantiating object and assign it to a otherwise private variable in the instantiated object, we go through the set public portal, and so the object's property becomes the target of the assignment. Reference the object dot property names, again same name that appears in the header, and we assign it in this case the name of the contents of a text box, okay, that's been converted to int32. So if I look back here, when this statement executes, it would go through a setter, and whatever's in whatever that converted value is in text box 1, that would be the value of this generic parameter named value. Okay, hopefully that makes sense. And then finally, what I want to show you, and I'm going to show you this just by way of a concrete example. This is actual program code that I have taken from my DICE class. It's possible to set up a public property that has both read and write access, or in other words, uses both a getter and a setter. And it's also possible to include more than just the bare minimum assignment statements in each component part. We can, add decision logic. We can add try-catch, control, and so forth. So here is my example. You'll notice that the method header appears here, and then that common method header is going to encompass both the get and the set part of this property. So the entire property begins with this brace and extends down through that last brace. It contains two parts. It contains the part that reads, and it also contains the part that writes. And if I want to control what's written to that property, then I can wrap it up with decision logic, or I can use try-catch in some way. Alright, so we are ready to look at the actual program code, and that will follow in the next module, next part of the module.